Good morning. This is Mr. Straits again, and we're looking at prisms and the volumes of prisms. And the very first thing that I wanted to bring to your attention was this Cavalieri's principle, which says that if two prisms have the same height and the same cross-sectional area at every level, you have to look at this picture for that, then they have the same volume. Now, if you looked at it as a deck of cards or a loaf of bread or something, and you started to stack things off, these two prisms here, the number 1 and the number 2, have the same, they have that same rectangular base there and here, all right? Those pieces are the same. And they are the same height from top to bottom. If you look at them, that's at least the way the picture is showing it, that they're the same height. And so these have the same volume. If you put a deck of cards, stand it straight up and down, or you fan it slightly so that it looks like this oblique prism in its volume. If you looked at it, they all have the same volume. Well, that's because the cards, no matter how you stack them up, the cards have the same area and the same depth or height in this case. So you stack those all together, you can even spin them and you'll still have the same actual volume. A lot messier of a formula, but here we go. And then on this third one, which is a larger, at least as far as its breadth, a larger triangular prism, but the cross section 1/2 times base times height. Base is 2. The base here is 6 and the height is 2. 1/2 times base times height. Base times height would be 12 and half of that is 6. This is base times height, and that would be 6. And then here's the base and there's the height of this, and it's still 6. All right, 6 square centimeters, or 6 centimeters squared. And since they have the same height by Cavalieri's principle, these three figures have the same volume. All right, we're going to take a look at the volume of a prism, and by formula, the volume of a prism is the product of the area of a base. I'm going to call that big B. All right, big B. Now, I'm not going to make a funny joke about big B, but big B is the area of the base, and that's this over here in the blue. All right, times the height. Okay, so the volume then is a product of those two areas. Now, if this base, which I called, in this case it looks like it's a rectangular prism, if it's an odd shape like a hexagonal and it's regular, then you would take that base and multiply it by the h, the height, and you'd get that same hexagonal prism. Okay. Find the volume of a regular rectangular prism. Oh, I wanted to go back up. Let me go back up one more time. There was one thing about this. So how do I determine the base? How do you decide which one is the base so that you can know, like in this picture, okay, which blue section am I going to use, and what am I going to call base, especially if I've got multiple areas or lots of options here. So if you look at this and look at it as a slice of bread, okay, and every piece as you go down through this is the same slice. Now this would be triangular slice of bread, but the same exact shape. Same exact shape as I cut this down like a loaf of bread or a deck of cards. Then you have that particular face is going to be your base. All right. So as we look at this particular example in the third slide, where I have 10 and 20, and then I got a 24. You could do this two ways. You could look at this 20 times the 24 and call that the base, and then because at the top up here it's also 20 times 24, or you could look at these two, the 10 and the 20, and slice my bread this direction, and each slice would be the same, and the height then would be the 24, and it really doesn't matter which you choose to use. Since I've got that one on there, I'll go ahead and use that. So we'll call the base area would be 20 centimeters times 10 centimeters, which would give us 200 centimeters squared for the base. Okay, h then is the third area, or this third length, and that's 24 centimeters. And the volume that we just looked at was base times height. which would be 200 centimeters squared for the area of the base, times the height, which would be 24 centimeters. If I take my 2 times the 24, I get 48. Now add my 2 zeros. That would give me 4,800 centimeters. And notice, 2 of them here, 1 of them here. It's going to be centimeters cubed. And all of our volumes are going to be in units cubed. All right? And that is my answer for this particular rectangular prism. Now, if you'd have done the 20 times the 24, again, you'd have 480. And if you multiplied it by 10 the height, using the first illustration I had been, you'd still arrive at that 4,800 centimeters cubed. Next slide. On this one, I put a little note up here at the top, and it says on prisms with different faces, the cross-section should be the same throughout the prism. That's what I was talking about earlier when I was talking about the loaf of bread, the slices that I'm cutting all the way through here. They better be the same shape, and that way I know that this is the base. Now I'm going to turn this one, since it's triangular, I'm going to turn this one on its side and draw a little cross altitude here. The altitude from the vertex to the side opposite. We'll call this 8 and 8, and if you'll look down here at this third side, this would also give me an 8. And if I chose, instead of writing 8, I'll split it up as 4 and 4. I have a right triangle. Now if I'm trying to find the altitude, which would be, in our case, the height of this base, okay, if I tried to find that, this piece right there, I'd be using the Pythagorean theorem, which would be a squared plus 4 squared equals 8 squared. And 8 squared is 64 equals 4 squared is 16 plus a squared. And if I subtracted the 16 from both of them, I would get 48 is a squared. And a is the square root of 48. Okay, and that's 3 times square root of 3 times the square root of 16, and 16 would be 4 rad 3. Okay, so a is 4 rad 3. That's the altitude. Now, if I'm looking for the area, the base, capital B, would be, the base is 8. That's this guy over here. 8 times the area, the height rather, which would be 4 times rad 3. And that's going to give me 32 rad 3. All right, that's the area of the base, so that's going to be in inches squared. Now, we looked at this, and the third dimension over here, I'm going to put a square or box around it. My h is 10 inches. So if I'm looking at this and saying, all right, so what's the volume? Well, the volume is the base, 32 rad 3, times the height, 10, and this is inches squared, and this is inches, would give me 320 rad 3. Oops, let me try that again. 320 rad 3 inches cubed. And I did something wrong here. Oh, I forgot my 1/2. So I forgot to put my 1/2 in here because that's far too great. So this is going to be 1/2 all the way down times 32 rad 3. 1/2 times 32 rad 3. So 1/2 times 320 rad 3 inches squared would give me 160. That looks a little better. Rad 3 inches cubed is my volume. All right, so try not to do what I did there, and remember when you're looking at a rectangle or a triangle that your area is 1/2 times base times height. All right, so my final volume, 160 rad 3 inches cubed. We'll look at one more triangle. This one looks more like a block of cheese. It's a right triangle prism, and so this one's a little easier to see the base. The base is going to be this right triangle down here. Okay, so if we did that, we would have a, let's go to a blue here. My capital B would be 1/2, we'll make sure we do it right this time, times 6 times 10. Well, 6 times 10 is 60, and half of that would be 30. And this would be in meters squared. So my base would be 30 meters squared. My height is that third dimension there, 5 meters. So my volume is base times height, or 30 meters squared times 5 meters, or 150 meters cubed. Remember, there's 2 of them here, 1 of them here, so it's always going to be in the cubed. And did I do that right up here? Yep, got the cubed there. So meters cubed, and that would be choice C. So answer in this one would be choice C. All right. Hey, I hope that gives you a good start on it. We're going to take a look at volumes of cylinders on Friday. Hope you're having a great week. Looks like the weather's going to be a little nicer for the next 3 days, a little warmer anyway. Yeah, hang in there. Reach out to me if you got any questions. I'll be announcing a Google Chat or a Google Hangout for next week. Bye.